Today we will explain dose response and why it is important to find the right dose. Everything dates back to 500 years ago when the humanist, physician and chemist Paracelsus quoted the following. He said, "All things are poison and nothing is without poison. Only the dose permits something not to be poisoned." Now, what did he mean by this? He meant compound, apparently harmless one, is potentially toxic if administered at high doses, and compounds typically considered toxic can be harmless and potentially even beneficial if administered at low doses. For any drug we are interested in, if the dose is set too high, safety and tolerability problems are likely to result, while selecting too low dose makes it difficult to establish adequate efficacy. Hence, finding the right dose is very important, and in order to determine the adequate dose, one need to characterize the dose response relationship. Characterizing the dose response relationship with respect to both efficacy and safety are the two key objectives of clinical drug development. Now, before we go deep into this, let us first illustrate what is the dose response relationship and why it is important. With the help of the smileys, we have shown how the quantity of doses administered have an impact on the state of a person. While a single dose can transform a person from sick to okay, three doses can make the same person sick to healthy. This curve or trend shown here, which captures the effect of the different doses of a drug on any subject, is well known as the dose response relationship. Dose response relationship is typically characterized by a sigmoidal model or a S-shaped curve. In our study, we are primarily interested in target dose estimation. More specifically, the minimum effective dose. Now, what is the minimum effective dose? Minimum effective dose is the minimum active dose which produces a desired threshold of delta over the placebo response. The clinicians typically provide this delta. We have so far grasped what is meant by dose response relationship. Now we will learn why it is important. The following figure shows the impact of fitting different dose response shapes to the same data. We observe that different dose response shapes lead to different target doses or MED for the same data set. Hence, the choice of dose response shape is very important. Error in this choice will lead to erroneous dose selection, which is quite harmful for the drug development process. In fact, both the FDA and Pharmaceutical Research and Manufacturers of America have identified poor dose selection resulting from incorrect or incomplete knowledge of dose response relationship for both efficacy and safety as one of the key drivers of the high attrition rates currently plaguing late phase clinical trials across the pharmaceutical industry. Hence, identifying the dose response relationship is very important. Now it is important to understand the role of a statistician in determining such dose response relationship. The statisticians indeed play a very important role, and the role of the statistician can be divided into several parts. Firstly, they need to assist in the design of the study, that is, to determine what is the optimal design, like the sample size, dose range, or the dose allocation ratio that would lead to the desirable target doses. Secondly, they need to advise the clinicians about the existing literature in the respective area in order to better understand what is applicable for the study they are interested in. Thirdly, in dose response studies, the true dose response shapes are not known a priori. The statistician helps in building methods that can help the clinicians to choose the most appropriate dose response shape for their case study with prior information. Example of one such approach is MCP mod approach. Summing up all, I would like to precisely present the objectives of our project. For a drug which is under development, we would like to show if there is any statistical evidence of drug activity. If yes, what are the doses that are significantly different from control? What is the dose response shape and what is the target dose? The above four questions are already addressed in the MCP mod method, which have gained quite some popularity over the past few years. We have analyzed the performance of the MCP mod and other methods and presented it in a review article. Though MCP mod and other existing dose finding methods are approved to be efficient methodologies for dose finding studies, often it happens, despite the proper characterization of the dose response shape in phase 2 clinical trial, the target dose recommended for phase 3 are not accurate. Further, though calculation of confidence interval is mandatory in many areas of clinical research, confidence intervals for dose finding studies have not yet been thoroughly investigated. So, in this project, we focus on developing a method which can accurately estimate the target dose and provide confidence interval for the target dose. Lastly, I would like to thank European Union and IDEAS for this wonderful opportunity to present my topic in a different manner. I hope you enjoyed the video.